So yeah, hi, I'm Katie Roberts. I'm from the BBC in Salford, and I'm going to talk to you today about some of the experience we've had at the BBC of getting rid of our monolithic architectures. So first off, a bit about me. I've been a developer for over 10 years. I became a developer by accident. I was working at Teesside University. I was put in an office with a guy who would only talk about development and Phil Collins. So I learned to program because I wasn't going to learn about Phil Collins for anybody. I've been at the BBC for coming up for 5 years now. I started off as a JavaScript developer in IPTV, or the smart TV systems, building JavaScript products for BBC Sport, for Olympics 2012, but I've also worked on BBC Sport and BBC Music stuff. And I'm now development lead for BBC Knowledge and Learning. So BBC Knowledge and Learning, the BBC has a remit to educate and to inform and entertain, and Knowledge and Learning cover the educate part of that. So we've got products such as BBC Bitesize, BBC Food, BBC Art, Earth, Science, Religion. Basically, we are BBC any other business. We're also responsible for the BBC Microbit, which some of you might be aware of. Does anybody here not know who the BBC are? That's the awesome thing about working at the BBC. I never have to explain that bit. Software development at the BBC. There are many different teams in the BBC. So there are news, sport, children's, knowledge and learning, media playout teams. And we're spread across many different locations across the country. So my team is actually split across Salford and Glasgow, but there are also teams in Cardiff and London as well. We create products for across 4 different screens. So by that we mean PC, TV, tablet, and phone. And we've got a lot of large projects, which have been written in a large number of development languages. Previously, the BBC used to write a lot of stuff in Perl. Then they moved to PHP and Java. And now they're moving more towards a Node world, which is great. There's a lot of legacy code. We've got some code bases that have been around for 15 years, in the case of BBC Food, and 10 years for Bitesize. So there's quite a lot of legacy code bases. We have very large audience numbers. So something like BBC Sport will pull in about 14 million unique users a week. The knowledge and learning team, we only get about 5 million unique users across our products. So we're quite a small team in BBC terms. We've got a lot of experience of delivering content to large audiences, and a few people have asked me over the conference how many developers there are at the BBC. So I think that in the software development, including testers and developers, I think there's around 2,000. It's difficult to know, though, because we all work in quite small, isolated teams. So we talk to each other's APIs, but we don't all get together in one room at any point. So I'm not quite sure how many developers there are at the BBC. So we've got some experience with monolithic code bases, and what I'd like to start off with is saying that I don't have a problem with monolithic code bases. The monolithic architecture is not intrinsically bad, and most of them, for the most part, do a very good job. The architectures fall down when they start to try and encompass new functionality or different functionality for jobs that they were never conceived of doing. And you start adding straps onto the code, you add bolt-ons, and then it's not documented necessarily, and then that developer leaves, and suddenly somebody else is picking something up, and it goes from being a beautiful, well-thought-through monolithic architecture to something which is more like this. It's got bolted-on code all over the place. It's a towering block of monolithic code that has existed since the dawn of time, or for at least since anyone who is in the building has been around. And when changes are made, the whole thing needs to be retested. It takes a long time to retest, because you never know what you've done and what change that might affect and how that will affect an audience member. Content's been bolted on, there's tightly coupled software, and it's not what we want, which is scalable, maintainable, reliable systems, which are more like this. This is how microservices feel in my head. This is not the BBC's view, this is just mine. This is microservices existing on the cloud, which is where I think it's a nice place to be. They're nest coupled systems, and they can be changed, and they can evolve at their own rate. So So now I'm going to tell you a story, because I do best when I'm telling stories. So this is the story of Bitesize. Bitesize is one of the BBC's flagship products. It's been going around for 10 years now. Has anybody here ever used Bitesize? Oh, that's nice. It exists in the UK and to help kids from schooling key stage 1 to GCSE level, and it really does form the backbone of our Educate system. So I asked my product owner for some stats on this. So here we go, flying slides. Bitesize has over 5,000 revision guides. It's got 2,500 decks of flashcards, which are used for the mobile app. It's got over 100,000 class clips, which are used for short-form video content for teachers in the classroom. It covers the separate educational system of all 4 nations. So anyone who's done GCSEs in the UK or Scottish Highers will know that there are a multitude of different exam boards, and Bitesize covers them all. It's got 38 different subject areas. And in total, that's over 300 separate programs of study and 5,000 plus topics of studies. 82% of all 15 to 16-year-old exam students say that they use Bitesize, and we pull in around 3 million unique users around the exam time. And 4 out of 5 kids say that it's helped them to feel more prepared for their exams. So that's good. It provides a lot of stuff for a lot of people, but users can find it quite difficult to navigate. So finding your content and what you want to do and what you're studying with that amount of noise around you can be difficult. This is the current Bitesize architecture. It's a standard N-tier architecture, which was written using to access the data content. We've got Equation Chef, which is it renders our equations using latex strings, and we've got something there called the LDP, which is the Linked Data Platform. It's one of the great BBC 3-letter acronyms. It's a data-driven website. It gives option to show all the content. So fairly straightforward. And it ain't broke. So Bitesize isn't broke, so why would we even think about changing it? So it's well maintained, but it's becoming very, very complicated to make changes. It's incredibly slow to deploy at the minute. It's got a lot of broken cucumber tests, and those become harder and harder to maintain. And we know there are things that we can improve in the Bitesize code base. Like I say, it's difficult to navigate for students. But the architecture just won't let us do that. And to be honest, like I say, it ain't broke. Why fix it? We had the concept of this, though. It's building a new facet of Bitesize, so the Bitesize app. The Bitesize app is mobile for Android and iOS, and it had the requirements that as a student, I want to be able to personalize content to my needs. I want to be able to choose my country, my language, and my exam board that I'm studying. And I want to have bite-sized and shorter form content, easier to digest for my exams. So basically, the idea is that if I'm on a bus going to school, I can do a quick bit of revision, and that's going to help me. And I can test myself on what I've learned, on how well I'm revising. So it's got all the facets of helping you get through your exams. So we're on to some more architecture diagrams. I've got to say, I'm sorry, I really love architecture diagrams, so I'm going to talk you through a few of these. You've got the current website, which I showed you before. We've got all the services coming into our PHP website. But now we want to do the same for a mobile. Now, a mobile can't hope to process as many data streams in the same way. It's going to take us too long to get all that content together, parse it inside the mobile, and we're going to have to build it in 2 forms. We'd have to build it in Android and iOS. And it's just not practical to do that. And also, you'd be using up a kid's data allowance. Every time you make a data call, you're using up their data allowance. And that's not going to end up with kids actually wanting to use your product. So we created a small node service called Einstein, which we spun up. It didn't take us very long to do. This, from end to end, it was about 3 months. So it's a good, lightweight service. And that powers the content of the app. So that allows the app to just make one data call for the pages that it's getting. We used a BBC service called Morph. Morph is a cloud-based system which fetches data from other sources, runs operations on that raw data, and then makes the output of those operations available for consumption. So it aggregates data sources from multiple sources. It was developed by the sport team. I know that those guys have done some talks for Nearform before. It's made to stand up to severe numbers of audience members coming to it at the same time, and it scales brilliantly. Plus, it's got a lot of built-in caching benefits, so it was great for us to use that. And then next, we need to personalize it. So we've got data coming into our app. How do we personalize that? So BBC also has another service called My BBC, which allows users to log in, get their user credentials. And they also have another system called UAS, which is the User Activity Service, another 3-letter acronym. The problem with the User Activity Service is it does not store full content, just short-form content, just short codes, so that it doesn't bloat its system, because it's a massive database, just recording what users are doing. So we built another service. We built Newton. Newton is a very, very small node service. This was about a month build. It just takes the content from UAS, rehydrates it with content from Einstein, and provides the app with digestible, personalized data that can be used, which is pretty sweet. This is a nice little service-based architecture, and it's got high availability. We don't want it 500ing during exam time. But that doesn't tell you anything about strangulation. Not talk much about strangling at all. What we're doing with the services, though, like Morph and Einstein, is slowly removing the responsibility or the brains of what the application is doing, and we're moving towards code that can work outside of the monolith while leaving the functionality of the original completely intact. So this is the strangler pattern, as described by Martin Fowler. What you're doing is you're taking your old code and you're gently replacing it with new code, slowly taking away the responsibility as you go. And the advantage of doing this is you might not know what every part of your old code is doing. I mean, I'm quite lucky. Some of the systems I've got are well documented, but I've worked in other code bases where they're not. And you just know what one part of it is doing. So write one part that takes that responsibility away, and you'll slowly start unraveling it like a piece of string. You'll slowly start getting a better picture of where you are with the old code and the new code. So with this in mind, what can we do with the Bitesize stuff now? Well, we're already getting from a lot of the data from the same sources for Einstein. So what if we started using that to power the web front end too, for preview content? And if we do that, perhaps we can start thinking about taking away the responsibility of the HTML view. We can start shrinking it down. We can start making it smaller, easier to manage. But you've got to be careful there, because Einstein's starting to become another monster. It was built to do one job and do one job well. It was built to power the mobile app, and it does that. So maybe we need another microservice in there. Ooh, was that me? Sorry. Which could then look after the HTML front end. And then once we've done that, we can start thinking about lifting and shifting the code across from the web world into the cloud as well. Because all we're looking at now is HTML, CSS, and JavaScript. It's not a complicated PHP app with unknown dependencies. We've slowly moved those out of its ecosystem. And Einstein and Newton and whatever our new service is, they're small enough pieces of the puzzle to evolve at their own rate and independently of the other elements around them. We can make changes which are transparent to our audience, which allow them to improve the offering. We can start thinking about adding features to the web page. For example, the personalization stuff is something we're really quite keen on getting into the BBC Bitesize website, but at the minute, we can't. This would allow us to do it, maybe using Newton as well. We can make changes to the site which are transparent to the user as well. We're not moving anything around. We're not redeveloping the site with a big bang. It's going to be gentle moving across. The teacher is still going to be able to find their old resources. Kids who've bookmarked the site, it's all going to still be in the same place. It's just got other things happening under the hood. Yes, we can do the careful migration of our data as well. This is not a quick process, though. It's something that we're moving living products across, and you've got to be very careful of how this affects your user base. You've got to ensure that you've got good tests in place to make sure that everything you're doing is not going to affect your audience. However, it is time well spent. Simple microservices that can evolve much easier to manage, easier to maintain, and if necessary, easier to kill off in 5 years' time when they are not doing the job you want them to do anymore. Replace them with something else, strangle them out of existence. Much more towards this way of thinking. So the monolith may not be gone, but it has reduced in complexity. Yeah. And we've got a path down which we know we can move to travel towards to achieve our goals. Right. I've talked far too fast. I do apologize. So I've got some graphs just to show you some more stuff about Bitesize. So the interesting thing about the Bitesize app is obviously it's there for kids during their exam time. These graphs show when the app actually launched, and if I can, there we go. There's an advert on the TV at this point just after The Voice. There's an advert there that's just after the Antiques Roadshow, and that one's after EastEnders, and you can see the spikes in traffic as we're getting things through. Another nice thing is, I might have to do this. This is showing, oh, everything's not fine. That's cool. There we go. This is during the exam periods. You can actually see the use of the app going up. So we've got, there would be an exam on this day. This is the weekend, and you can follow it. And it's quite nice to see how users are actually working with your product. I think finally is that kids are really not very transparent when they leave you feedback on the site. So I thought it might be nice for you to know a couple of things they've said about it. So first one is, awesome. Everybody doing GCSEs needs this to help them revise. I tried every other revision app, and they don't work for me, but this one does. I like that one. Another one, I'm in year 7, and we're doing SATs again. I was told to study for a science test, and I want to be a surgeon, which means I need to be really good at science. If I fail, I'll be placed in a low group. I had this app for an hour, and I already have more knowledge than I have had in my entire life. Please download this. And as Shia LaBeouf always says, just do it. But you also get things like, why do I want to do homework on my phone? Awesome. Okay, thanks very much for listening. Just to let you know, BBC, we're hiring at the minute. If you're interested in coming and working in Salford as a web developer who gets to work on really cool stuff, please give me a shout. Okay, thanks.